Okay, let's solve another one. This is no paper, no pen kind of problem. You have to do it orally. The man is holding two string on both the sides. The man weight, let's make it 60 kg this time. He's a stronger one. The platform is still 20 kg. So he's holding rope on both his hand, and he is applying some force symmetrically. So the tension in this string and in this string would be the same. So the question is now, how much force should he apply on both the ropes so that the whole system remains as it is? So your answer is T should be equal to how much? Yes, it should be equal to 200 Newton. Right? That's the right answer, and I know how you did it. You did it in a smarter way this time. You took the platform and you took the man both as a system, and you had T, you had T, you had T, you had T. There are 4 T. That should be equal to the total weight of the system, which is 800 Newton. So you got the T as 200 Newton. That was pretty smart. Good. So let us quickly solve one more no paper, no pen problem. I have a horrible drawing, but I hope that would not deter in our learning of physics. Okay, so this is our system. 2 pulleys are attached to the platform. There are 4 pulleys attached to the ceiling, and the man is again applying force on both the sides. And the question is again the same. How much force should he apply on both the ropes if he is applying the same force on both the ropes for the whole system to be stationary? This time, as you can see, because of the mechanical advantage, the force applied would be much lesser if we have the same man of 60 kg and the same platform of 20 kg. This time, if you have to calculate how much force is the man applying, then that could be calculated by looking at the FBD of the man and the platform. There's a tension here, T, 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 T. There are 4 T on left hand side, similarly 4 T would be on right hand side. There are 8 T, which are 8 T of force is being applied on the platform man system. And the total force in the downward direction would be 800 Newton. So T would come out as 10 Newton. As you can see, this is the advantage of using pulleys. The total force that you have to apply to keep the same system stationary becomes much lesser. Okay? Okay. Okay, now suppose we have a sphere and there's a vortex. There's a conical structure. It's a 3D structure. We are drawing it in a 2D plane, but nevertheless it's a sphere and it's a conical form of vortex, and this is kept held stationary like this. Suppose the cone is actually fixed at this point, and this angle is 60 degrees, so is this angle. The weight of the sphere is W. Now you have to calculate the magnitude of the normal reaction acting at both the contacts. So it's a pretty simple, straightforward problem. Get your act together, draw the FBD properly first, and from there you can see things through very easily. So get your answer. The FBD of the sphere can be drawn. W, weight, would be acting downward. There will be a normal reaction like this and normal reaction like this. Both will be the same, because from the FBD you can see the horizontal component have to cancel out, so both have to be the same. Now the angle I have told you, if this is 60 degrees, then the normal reaction makes an angle of 60 degrees with the vertical, and that's very basic trigonometry geometry to find that. So the normal will be making an angle of 60 degree with the vertical, 60 degree with the vertical. Now in the vertical direction, you can write the normal component of forces upward is n cos 60 degree, and there are two components from both sides, so 2 times n cos 60 degree. That should be able to balance W. So n should be equal to W. So the normal reaction that you have, that is equal to W. We are dealing with basic geometry actually. Simple? Okay, if it is simple, how about this? This is a sphere, although it doesn't look like one, but consider this is a sphere. This angle is 30 degrees, suppose. And again, the weight of the sphere is W. Now you have two contacts. You have to find the normal reaction at each contact. So doing that shouldn't be very difficult, and doing that shouldn't take too much of time. So do that easily and quickly. Okay, let's draw the FBD. W would be downward. The normal reaction from this end would be acting horizontally, perpendicular to the plane of contact. So this is a normal reaction from this surface, N1. And the normal reaction will be perpendicular to the plane of contact, and the angle which it will be making with vertical would be 30 degree. So the normal reaction from this contact would be like this, 30 degree. Let's call it N2. Now N2 cos 30 degree should be equal to W, because these are the only two forces in the vertical line. So N2 should be equal to 2 times W upon root 3. And in the horizontal direction, if you see, N2 sine 30 degree should be equal to N1. So N1 would come out as W upon root 3. Easy. Okay, so we'll be solving one last problem before we move on to the next section.